Welcome wherever you are. My name is Teacher David. I want to take you through Maseno Chemistry Paper 3 and see what they predicted. So let's start. Let's start with question 1, question 2, question 3. Question 1 has got 19 marks, question 2 14, and question 3 7 marks. You are provided with solution Q, 2 molar hydrochloric acid, solution P, 0.5 molar sodium thiosulfate, and solution R, which is sodium carbonate. Procedure 1. But before we go to procedure 1, I want to remind you a very important aspect in chemistry. Wherever you see a solution given in terms of morality, like this, it is 2 molar hydrochloric acid. 2 molar means that 2 moles are in 1,000 centimeters cube, because this is morality, and we know very well that morality is the number of moles in a liter. A liter is equal to 1,000 centimeters cube. For the sodium thiosulfate, it means that 0.15 is the number of moles in a liter. In a liter, what is a liter? A liter is 1,000 centimeters cube. That is very important and very critical for you to understand. Measure 20 centimeters, and in practical, the most important thing is the procedure. Some people think when we read the procedure we are wasting time. The most important thing in a practical is to understand what is happening in the procedure, which solution and which one is reacting to the procedure. So this, from there you can connect and understand what you are required to do. So always understand the procedure. Measure 20 centimeters of this solution P into a glass beaker. Place the beaker on a white bar like that, and there is the X mark. Measure 20 of 2 molar hydrochloric acid, solution Q, using 50 centimeters cube measuring cylinder. Put the acid into the glass beaker containing sodium thiosulfate and immediately start off the stopwatch. Determine the time taken for the X to become invisible, that is to be obscured, that is to disappear. Repeat the procedure by measuring different volumes of the acid and adding the volume of the distilled water to complete the table. So you just need to use this table, like volume of the acid, if it is 20, the volume of water is 0, and the volume of the sulfate is going to remain constant. So you just follow instructions and then fill the table with the time seconds. So you can give it in 20 seconds, 40 seconds without bothering about the decimal place. And then the reciprocal of the time, you press, if suppose, let me give you the first value, like the first value was 32. So the first value was 32. Now that is 32 seconds. It took 32 seconds for the cross to become invisible for the first experiment, the first. So how do you get the inverse? The inverse, you press 1 over 32 and you get the answer. Then you write it to 3 significant figures or to 3 decimal places. And then you get, that is 0.31, like that. So here you will write 3031. That is now the correct way of doing that. So we are going to give you the mark for the decimal for maintaining 3 decimal places all through from here to the end. That is fine. So for maintaining the decimal point, 3 decimal point, we will give you 1 mark. For accuracy, we will give you 1 mark. For the complete table 2 marks. If anybody fills this table with anything until it is complete, that person will score 2 marks. It doesn't matter what, so long as a person here uses any numbers, he will feel like as long as the table is complete, that person scores 2 marks. And then there is the true value, that is to another 2 marks. And this is the values that we got, and we need to use that. Complete the table. We have Now we need to plot a graph of 1 over t, that is the rate, against volume of the acid. Always remember that the graph of the rate will always pass through the origin. So if it does not pass through the origin, that graph, you are going to score 0. So this is the graph of rate against the volume of the acid. It will always go through the origin. So make sure you use the points which enables the graph to pass through the origin. Please always remember that. Remember to label the graph 1 over t in seconds. Here we have used the standard form. So you can see we have 22, 23, 24 up to 32. Where did we get those values? Look at our table. Our table is 0. The first rate is 0.031. So we have written this number in standard form. So that is 3.1, or we can write it 1, 2, 3 into 4. That will be after 1, the special standard form times 10. How many steps? 1, 2, 3. So 1, 2, 3 to negative 3. So now we will have a 31, 32, 33 up to the end. And remember, when you write a standard form, if you are moving from, this is 0.031, if you are moving to the right to look for the number, then remember that the power is negative. Always you should know that. Now this is the graph. Explain the shape of the graph. Why is the shape of the graph like the way it is? It means that the rate of reaction increases with an increase in the concentration. Hence more reagent, more frequent correlations occurring. Are you seeing that? That is, it means that as the rate of reaction increases with increase in concentration. Well, that is very correct. That's very true. Remember the factors that affect the rate of reaction. From the graph, determine the time taken for the cross to be obscured when the volume of the acid is 15. Now you look at the graph. Our 15 is here. This is 14. It means this is 15, right? So you draw a dotted line to where you have the curve. Then go across and read this value here. That is very important, and you write your answer. For this learner, it was 20, this is 26 and this is 25. So this is 26, 1, 2, 3, 4, 5. So this is 26, 25.1.2, 0.3. Oh, this is 1, 2, 3. That is 3 times 2. So that is 25.6. So for this learner, it is 25.6 times 10 raised to power negative 3. That is, or the rate will be, you put this 1, 2, so it will be 0.0256. For this learner, it will be that one. The volume of the acid used if the time taken for the cross to be obscured is 40 seconds. If the time is 40 seconds, what will it be? So 40 seconds. So first get the reciprocal of 40 seconds, which is 0.05. So for 0.5, now you need to read the volume at that point. So for our case, 0.025 is simply 25 times 10 raised to power negative 3. So we go to where we have the rate at 25. So then 25, then you draw a dotted line across, you come down, and then you read the volume here. So this one could be, if this is 14 and this is 15, 41, 2, 3, 4, 5. Therefore, it is 2, 2. So it is 14.1, that is 0.4.5. So it is 14.5. For this learner, the answer is going to be 14.5 centimeters cube. Very good. Now let's move on to the next part 2 procedure. Using 10 centimeters cube of using a 10 centimeters measuring cylinder, place 10 centimeters cube of solution Q into a 250 volumetric flask. Add about 200 cl of distilled water, shake well, add more distilled water, top up to make label the solution T. So first remember what is solution Q. Solution Q is hydrochloric acid. That is very important for you to know what's happening. Then fill the bullet with T, which is now diluted HCl, because Q is HCl. Therefore, when we add the water, we dilute that, but it still remains to be HCl. Pipette 25 centimeters cube of solution R. Which one was solution R? You go back and check. Solution R is sodium carbonate. So here, an acid is going to react with a carbonate, and you expect a base and an acid. We use phenolphthalein and titrate. So we have been given the table. So if your value, the value is 6.2, always take initial to be 0.0. 0.0 for in the case of to get the marks. We want you to get all the marks. This table must be complete. There is this one mark for CT. CT stands for complete table. So any students who fills this table with anything, that is any number, and the table is complete, that student will score 1 mark. Then here this is 6.4 and this is 6.6. Yes, so for this arithmetic, when you subtract 6.4 minus 0, the answer is this. So at this complete, you will get the whole 5 marks. So, but you need to understand what's happening here. It is sodium carbonate reacting with HCl, but this HCl is not the original one. It is the diluted one. Very important. Original was Q, and we have used the 10 centimeters of the original Q, diluted it into 250 centimeters cube. Do you know what that means? It means that the number of moles in 250 centimeters cube solution T is the same as the number of moles in 10 centimeters cube solution Q. Very, very important for you to understand that. Very critical. Did you hear what I said? Please get it. So let's go to the question. Determine the average volume of solution T. Average volume, you simply add 6.2 plus 6.4 plus 6.6. Now calculate the number of, determine the number of moles of the acid in the average solution T. But there is one thing I said here. I said we know the concentration of solution Q. That is the HCl. The HCl, you were given the concentration as 0 point. We go back to the procedure. We were given that solution Q, it is 2 molar hydrochloric acid. So that means the number of moles in 1,000. So we will start there. That 2, capital M, moles of Q is in 1,000 centimeters cube. 1,000 centimeters cube. We took 10 centimeters cube and diluted. So we want to know 10 centimeters cube will contain how many moles. So that is 10 times 2, you divide by 1,000. You hear that? So take your calculator and you press. I don't have 20 divided by 1,000. You get it is 0.02 moles. Now you need to know that the number of moles in the 10 solution Q that we diluted to 250 will be equal to the number of moles of T in 250. Therefore we say 250 centimeters cube solution T contains 0.02 moles, because the number of moles in 10 centimeters cube solution Q is equal to the number of moles in 250 solution T. Remember that. So now, so the average volume, that is 0, that is 6.4 centimeters cube solution T will contain how many moles? So it is 6.4 times 0.02, you divide by 250. That one will be times 6.4, then divide by 250. So let me repeat that. 6.4 times 0.02, get the answer, divided by 250, and it gives you 0. So the number of moles is 0.00 0 1 2 1 2 3 4 5 1 2 moles. So this is the number of moles of T used. Concentration of solution T in moles per liter. Yes, now at C, concentration, determine the concentration of R. R is the carbonate. So the carbonate reacted, you must know how to write the reaction between the carbonate and the HCl. So that one is the most important. So it was sodium carbonate. Was it sodium carbonate? It was sodium carbonate. Solution was sodium carbonate with HCl. You should be able to know the reaction, how it reacts, plus HCl. Actually, it goes to form sodium chloride plus CO2 plus water. But you see here, we are going to have 2 here. And we are going to have here 2. So therefore, the ratio is 1 to 2. So the HCl, so the carbonate to the HCl, the ratio is 1 to 2. That is very important, which means that now the solution, the T that reacted with the T is the HCl. So the moles of HCl is 0.005, 0.000512. So we will ask here what will be the moles of the carbonate first. So the moles of the carbonate will be actually a half. So it is a half times 0.000512. After that, now this is the number of moles of R in 25, because R that was used is 25 centimeters cube. Remember that pipette 25 of solution R. That's why you need to understand the procedure. Now here you take your calculator and get the answer. That so it is going to be 0.00021234256 moles. So this is the mole of the sodium carbonate. Very good. In 25 centimeters cube. So when you are asked the concentration in moles per liter means molarity, because it is a number of moles in a liter. A liter is equal to 1000 centimeters cube. So you simply ask if 25 centimeters cube of the carbonate, of sodium carbonate, contains 0.000256. What about 1000 centimeters cube? Because molarity is in 1000. So therefore it is 1000 times 0.000256. You divide by 250 and you get your answer in moles, in molarity. So that is answer times 1000 divided by 25. You get it is 0.010 mole. Capital M stands for moles per liter. So molarity you give it to 3 decimal places. Molarity you give it to 3 decimal places. So in chemistry, always you can be sure to give to 3 decimal places. You are provided with solid V. Carry out the following test and record your results in the spaces provided. Put the solid V in a pouring tube. Add 10 centimeters cube of distilled water. Filter the solution and divide the filtrate into 3 portions. Retain the procedure. So this one contains a soluble and insoluble solute. So you will be given the observation and then you write. So the solute partially dissolves, form a colorless solution. So if it forms a colorless solution, then it means the colored ions are absent. The colored ions are absent. Therefore, you write, and then a white residue, it means it is insoluble. So when you are filtering, you tell us about the residue and the filtrate. Yes, so it solves. Of course, if it is a filtrate and there is a residue, it means the salt was not completely soluble. It dissolves partially. It dissolves partially. That's what the thing you need to understand. Therefore, so solid V dissolves partially to form a colorless filtrate. The filtrate is colorless. So if the filtrate is colorless, then it means the colored ion, which is copper 2, that is blue, the ion 2, which is green, and the brown ion 3 is absent. Then insoluble carbonate. Insoluble. The residue is insoluble. The white residue remains. If it is the white residue remains, then it means it is insoluble. White residue. So white residue, it means the residue is insoluble. Solid. You can call it salt or solid. To the first portion of the filtrate, add aqueous sodium hydroxide. When you are using sodium hydroxide, you expect 3 observations. Number 1, a white precipitate is formed, insoluble. Number 2, a white precipitate is formed, soluble in excess. Number 3, no white PPT. So those are the only 3 observations, and you need to know the answers for each observation, because that is the only thing we are testing. So this one, there was no white precipitate. You see that? So if there's no white precipitate, then the sodium ion, the potassium ion, ammonium ion are present, because this one, they don't form any white precipitate, whichever whatsoever. They don't form a white precipitate. That is fine. Dip a clean spatula into a portion of it, ignite it, a Bunsen burner. Then the observation is that a yellow flame, golden yellow. For golden yellow, it means it is sodium ions that are present. To the second portion of the filtrate, add lead 2 nitrate, then a white precipitate, and then warm gently. That's now where we want to concentrate when you warm. So if you are adding lead, remember all chlorides are soluble except lead chloride and silver chloride. But lead chloride is soluble in warm water. So when we warm, we dissolve that white precipitate. So a white precipitate dissolves in warming. Then it means it is the chloride ions which are present. That is very okay. Heat the first portion of the residue in a test tube gently and strongly. Test the gases produced. So when you heat, the colorless gas is produced, changes the moist blue litmus paper into red. So the colorless gas produced, which changes moist blue litmus paper to red. So if a gas changes blue litmus to red, it means that gas is acidic. Yes. So you can write acidic gas present, or you can simply write H positive present. Then the yellow residue when hot changes to white when on cooling. So if the yellow residue is white on cooling, yellow when hot, that is zinc oxide. Zinc oxide, that's how it behaves. Therefore, you don't write for us zinc oxide here, you only give us the ions present. Therefore, it is zinc 2 ions present, because the compound is zinc 2 oxide, obviously. To the second portion of the residue, add dilute nitric acid and divide the solution into 3 parts. observation if ever-sense occurs. If ever-sense occurs, then it means it is a carbonate or a sulfite. A carbonate or a sulfite is present. Now this one will dissolve. The carbonate will dissolve in the nitric acid and will form a colorless solution. Because it's a carbonate with an acid, it is going to form a colorless solution. To the first portion of the sodium, to the first portion of this solution now, add sodium hydroxide dropwise, a white precipitate soluble in excess. If a white precipitate is formed soluble in excess, then the ZAP is present. ZAP. ZAP stands for zinc, aluminium, and lead. So these are present. That is very correct. Are present in the residue. Then to the second portion, add aqueous ammonia dropwise in the. So for aqueous ammonia, it is specifically used to test for zinc ions. So if it dissolves, if it forms a white precipitate soluble in excess, then the zinc ions are present. If it doesn't, then for this one, a white precipitate is formed soluble in excess. That confirms the zinc ions are present. Very important. To the third portion, add a few drops of acidified potassium dichromate 6. Orange acidified potassium remains orange. So if it remains orange, then it means it is the carbonate that is present. But if the orange color changes to green, then it means a sulfite could be present. For now, it is the carbonate which is confirmed because a carbonate cannot change this one. So you don't need to tell us that the sulfite is absent. You need to tell us what is present. So it is confirmed that the carbonate was present. Organic. You are provided with liquid A. Carry out the following tests and record the observations. To the first 1 centimeters of liquid A, add 1 centimeter of distilled water. Now we have a liquid and we are adding water, distilled water. Now if the learner says here that it dissolves to form a colorless solution, that is wrong and you get 0. Because a liquid cannot dissolve in another liquid. That's not what we say. Here you tell us whether the liquid is miscible or immiscible, whether it is miscible or immiscible. That one is very important for you to know. So did the distilled water dissolve mix in liquid A to form a miscible liquid? Yes. So forms a homogeneous layer, or it is miscible. That is, it means the compound is polar. It is polar. It is polar. The key word is polar because anything that dissolves in water, it must be polar for sure. To the about 1 centimeter cube of A, add acidified potassium manganate. Manganate is purple in color. So if the color changes to colorless, if acidified potassium manganate is decolorized, then it means the alkene, the alkynes, and the alcohol is present. So these three are present, suspected to be present. We add bromine water, 2 drops, 3 drops. Then bromine water is yellow. If the color changes to colorless from yellow, then it means the double bond, triple bond is present. But if the yellow bromine color persists, remain the same, it means it is the double bond, the double bond is absent. For this case, the yellow bromine water persisted, therefore this and this are absent. Very important. Thank you very much. Usikue mchoyo wa kushare, usikue mchoyo wa kulike, because you need to support our work by liking. That is the only thing you help us with. Like and share. Is it difficult? Thank you. Very, very important. Thank you.